The focus of this video is to learn some of the basic vocabulary from Unit 9. We won't touch on all of it, but the really important stuff we will talk about in this video. And then we're also going to talk about how to solve for the radius and diameter of a circle, which is one of the assignments that you have on Khan Academy is to solve for the radius and diameter. So those are the only two things that this video is going to focus on. So some of the vocabulary that you do need to know. So a circle is a round figure where all the points on the boundary are the same distance away from the center. Okay, another fancy way to say this is equidistant. So you might see that in the vocabulary on Canvas. So it's the same distance away or equidistant from the center. So a circle, we name it according to its center. So if I had some circle here, and the point that's right in the center, let's call that point M, I would call that circle M, okay? So I put the name of the center right next to it, and then I draw a little circle with a dot in the middle of it. So that's how I refer to a circle in geometry. Next thing, the radius. So this is just the distance of the segment. So it's a segment, a starting point and an ending point. It's a segment that goes from the center of the circle to any point on the boundary of the circle. So let's say if we look at our circles down here, there's the center, that's where the segment starts, and then it can land anywhere on the boundary. So here the radius lands right there on the boundary. That is the segment that goes from the center to some point on the boundary of the circle. I could have just as well made a radius in a different spot, so just as long as it's starting in the center and it goes to some point on the boundary, let's say maybe this point instead, that's a radius, or this is a radius, or this is a radius. I can have as many radii as I want to, okay? While a diameter is going to be the distance of the segment that goes from one side of the circle to the other. Okay, it has to pass through the center, so that's really crucial. So starts at one side of the circle, goes straight through the center, has to pass through the center, and out to the other side. It's a straight line, okay? So that could be a diameter, or if I start here, go through the center, out to the other side, that would be a diameter as well, okay? So let's think about the relationship between the radius and the diameter. What do you think the relationship is? So let's say I had a radius and it was a length of 2, okay? What would the diameter be? So the diameter, if it goes through the center, what would the length of the diameter be? Well, if you're looking at these two and you've derived, okay, the relationship is probably that if I take the radius and multiply by 2, that's how I get the diameter. So the diameter is double whatever the radius is. So this diameter should be a length of 4. Likewise, if the radius was a length of 10, what would the diameter be then? If we double it, it should be 20. Okay? So we can use that same logic even going backwards. Like if we started with the diameter first, like let's say we were given a diameter of 100. What's the radius then? So then the relationship is that if we cut the diameter in half, that gives us the radius. So 100 divided by 2 is 50. So then the radius is 50. Or if we look at one more, let's say our diameter was 12, what's the radius then? Should be 6. Okay, so that's the relationship between the diameter and the radius. And then lastly, our circumference is going to be the distance around the circle one time. So if we pick some spot to start on the boundary of the circle and we go all around the outside of it and then back to that same spot, that distance is the circumference. So it's kind of like if you imagine running on a track. So that point that you start at, and if you do a full lap around the track and come back to where you started, that would be the circumference. Okay, I did a full lap around the circle. Okay, so a couple more abstract pieces of vocabulary. So I really think this picture here is helpful for a lot of this vocabulary that you see. So for example, a chord. This would again be a segment that goes across the circle, but this one, it doesn't have to go through the center. Okay, so I see that a chord here, it doesn't have to go through the center. It can, but it doesn't have to. Okay, and then a diameter is actually going to be a type of chord. Okay, so that's really crucial. We're adding on to our definition of diameter. It's a type of chord that goes through the circle and it has to pass through the center. So both a chord and diameter, those are both chords. A diameter is just a special chord that goes through the center. Okay, but you could have a chord that doesn't go through the center. That would just be a normal chord, but a chord that goes through the center is a diameter. Okay, and then a couple other pieces. So secant, that would be a line. So a line instead of a segment. Remember, a line has arrows at both ends. Okay, where a segment has endpoints. So it has to be a line that intersects the circle at 2 points. So I see that my secant line in orange here intersects the circle right here at this point and again at this point. So it hits it right at 2 separate points. And then a tangent is a line, again, that intersects the circle only at 1 point. 1 point and 1 point only. So it's kind of like a rock that's like skipping off the water. It just hits it at one spot and then jumps off. Okay, only hits or only touches the circle at one spot. Okay, and then an arc is actually just a piece of the circumference. So recall we said the circumference was the distance around the circle one time. So if you didn't take a full lap around, like let's say you started here and then you only got this far when you were running, that would be an arc. Okay, so I didn't go the full distance around the circle, I only made it however far of the way that you made it. So an arc could change, so that the size of an arc could change depending on like how far you run around the circle. So I could have an arc that's this big, I might have another arc that's a lot bigger. So maybe I made it farther around. So this could be an arc as well. And we'll talk in another lesson about different types of arcs, arcs that are smaller, arcs that are bigger, but it's just part of the distance of the circumference. Okay, it's not the whole circumference, it's just a piece of the circumference. All right, now we're going to go through this picture here and look at all of these lines or segments and determine what the best name for each of these are, depending on the vocab that we have here. So what I'm going to encourage you to do if you've made it this far in the video is to pause the video and see if you can come up with an answer for each of these 5. Unpause it, and then I'll tell you what the correct answer is. So in Circle C, AC is a segment, and it starts at the center and goes to a point on the boundary. So that would be a radius. That would be the best word to describe AC. All right, GE. What about GE? So from G all the way to E, notice how there's arrows on both ends. So this would be a line. And it only hits the circle at 1 point. It only hits it at point F. Okay, so this would be a tangent line. Okay. All right, next I have BH. So from B, and notice how this does not have arrows on the ends. So this would just be a segment. It starts from point B, goes to point H. What would that segment be called? Okay, so it's not going to be secant, because remember secant is a line. So instead, this would be a chord. Okay. Okay, next we have A to D, so from point A all the way to point D. Remember that C was my center, so this is a segment and it goes right through the center, okay? It is a type of chord. It's a very special type of chord that goes through the center, so that would be a diameter. Okay, and the very last thing here is line GK. Okay, so that is going to include the arrows on both ends this time, and it does hit the boundary of the circle at 2 spots, so this would be a secant line. Okay, and the last bit of vocabulary that we have has to do with that tangent line. So when tangent lines touch the circle at one point, we know that to be true, right? Where secant touches it at one point. Okay. We have actually a special name for that point where it touches. So we're going to call that point the point of tangency. Okay, so really fancy. So tangent lines are always going to be perpendicular to the radius of the circle. So let's back up and kind of look at what that means. So that point right there, that is the point of tangency. It's where my tangent line is hitting that circle one time. Okay. Tangent lines are always perpendicular. Perpendicular means intersecting at 90 degrees. So it's always perpendicular. I'll just write perp for perpendicular. To the radius of the circle. So when the radius and the tangent line intersect, when they touch each other, they should always intersect to make a 90-degree angle. So we'll look more about how we can do problems with that idea later on in future lessons, okay? So we'll skip those problems for right now, but kind of just to review, take a moment, pause the video, see if you can answer these 3 questions, and then we'll go over them right after that. So what is the relationship between the radius and diameter of a circle? Okay, so if I take the radius and if I multiply it by 2, okay, whatever the length of that radius is, we can think about that in a circle. If I take this distance and multiply it by 2, that is going to give me the diameter. Okay, where if I have the diameter and I divide that by 2, if I divide this by 2, that's going to give me the radius. So let's say I had a circle, there's the diameter. If I wanted the radius, I just cut this in half, I divide it by 2, and that's how I get the radius. Okay. Next, compare and contrast a chord and a diameter. Okay, so a chord is a segment that does not have to pass through the center. So it's a segment and it does not have to pass through the center, where a diameter is a type of chord. So that means it's a segment. So it's a diameter is a type of chord that has to pass through the center. Okay, so that's the difference between the two. And then lastly, explain what the difference is between a secant and tangent line. So a secant line goes through the circle at 2 points. So it hits the circle's boundary at 2 points, where the tangent line only hits it at 1 point. And remember, that 1 point where it touches is called the point of tangency. Okay? So that 1 point where it hits the circle is the point of tangency.